trigonometric functions of acute angles. Consider this right triangle. Suppose this is our theta. This side here is A, this is B, and this is C, where C is the side hypotenuse. Now, to find the values of the sides of a triangle and its angle measures is called solving triangle. Solving triangle means finding the value of all sides and finding the value of the angles. But in this case, since this is a right triangle, we know for a fact that this angle here is 90 degrees, and the sum of these two angles, let's say, suppose this is alpha, the alpha and the theta is 90 degrees. Okay? The sum of alpha and theta is 90 degrees. Now, solving a triangle can be accomplished by using special trigonometric ratios associated with each acute angle theta. Note that the theta here is less than 90 degrees, and also the alpha here is also less than 90 degrees. So they are actually acute angles. Now again, to solve this one is to find the ratios that is associated, or the ratios that are associated with each acute angle. And the ratios are actually A over C, C over A, B over C, C over B, A over B, and B over A. These ratios with respect to acute angle was given trigonometric names, and these are the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant, where the sine theta is equal to B over C. Note that this is our theta here, and the sine theta is B over C, where B is the opposite side and the C is the hypotenuse. Okay. Then we also have the cosine theta, which is the ratio of A and C, and A with respect to the theta is adjacent side, is the adjacent side, so that's adjacent, and again C is our hypotenuse. Then the tangent, then the tangent theta is B over A. B is the opposite side and A is the adjacent side. Now we also have the cosecant theta, which is C over B, and C is the hypotenuse and B is the opposite side. Also, we have the secant theta, which is C over A, where C is the hypotenuse and A is the adjacent side. Lastly, we have the cotangent theta, which is A over B, where A is the adjacent side and B is the opposite side. Of course, if we consider the alpha, the opposite side will change, but the hypotenuse will stay the same, and the adjacent side will also change. If our angle to consider is alpha, the opposite side is A and the adjacent side is B, but the hypotenuse will remain C. Okay, but we can follow the same definition. Now, what can we observe here? It is important to note that a right triangle can be oriented in many different ways, but irrespective of the orientation, the hypotenuse is always opposite the right angle. Okay, so whether you consider the theta or the alpha, the C, which is the opposite, which is the hypotenuse, is always opposite this right angle. And also, since the hypotenuse is always greater than A, at the same time, the hypotenuse is always greater than the side B, it is important to note that the sine and the cosine are always less than 1. Why? Because their denominator is C, which is greater than A and greater than B. And the cosecant and the secant are always greater than 1. Why? Because the numerator of the cosecant and the numerator of the secant are C. Okay? And C is greater than B and C is greater than A. Now, as you can observe, there are terms here. There are trigonometric names with co. We have the cosine, the cotangent, and the cosecant. Actually, the prefix co there in cosine, cotangent, and cosecant means cofunction. So again, if we consider the right triangle, this is the right triangle, this is C, this is B, and this is A, and this is theta, and this is alpha. Note that the alpha here can be computed by 90 degrees minus theta. And also, if the sine theta is B over C, you can consider also here that B over C is also the cosine alpha, or the cosine 90 degrees minus theta. So that's why the cosine function here is a cofunction of sine. Also, the tangent theta, which is B over A, is the cotangent alpha, which is the cotangent 90 degrees minus theta, and so on. So we can continue this same approach or same concept. The secant theta is C over A, and C over A is also the cosecant alpha, which is cosecant 90 degrees minus theta. So from this, we know that the cosine is the cofunction of sine, the cotangent is the cofunction of tangent, and the cosecant is the cofunction of secant. Also, we have the cosine theta, which is A over C, and A over C is sine alpha, and sine alpha is just sine 90 degrees minus theta. Then the cosecant theta is C over B, which is secant alpha, and the secant alpha is just secant 90 degrees minus theta. And the last one, which is the cotangent theta, is A over B, which is the tangent alpha, also the tangent 90 degrees minus theta. So it is very important to be familiar about the functions, the trigonometric functions and their cofunctions, especially if we are already in solving equations involving trigonometric functions.